All right, what do you say? Let's do this. Last topic for this unit. We're going to compare the areas and perimeters of similar figures. Ooh, we're going way back, aren't we? Similar figures. Sides are in proportion, the same ratio. Correct. All right, those are two figures are similar if their sides are in the same ratio. So on the back, the second page of your notes today, if you flip it over, you guys got a large sheet of graph paper. Up in the corner of your large sheet of graph paper, I'd like you to please graph a 3x4 rectangle. And the 3 will be the vertical part of it. So graph just quickly 1, 2, 3 by 4 rectangle. 1, 2, 3, 4. 3 by 4. And however you want to label it, original, you put a big O in there. You go ORIG, however you want to. That's our original rectangle we're going to go with. And sorry, you got to keep doing this, but flip back, and I need your help filling out the table. What is the perimeter and area of my original rectangle there? What's the perimeter and the area? I need you to help me fill in. Let's first start with perimeter. 22, perimeter. 14. I can't believe I'm calling on somebody for this, but area of that one, 6, 12. All right, good. Now as a class, we're going to make a decision. I hope we're going to make a decision. I want to go back to the graph paper and make a rectangle that's similar to that one. Anybody got dimensions for me? What do you want, class? Dimensions for this similar one? Let's not get out of control here. Avery?
6 by 8.
6 by 8. There's a classic rectangle one. So everyone go ahead, graph a 6 by 8 somewhere on your grid. 6 by 8. And call that rectangle Roman numeral 1. 6 by 8. And go back and what's the perimeter and area of that? 10 when you're ready. Perimeter?
28.
28. We doubled the size and the perimeter doubled. Look at that. How about the area? 6?
48.
Ooh, wait. Did the area double? Ooh, that's interesting. All right. We still need more, though, to find a pattern. The perimeter's doubled, but the area did not. Huh, okay. Next up, what size triangle you want to do next? That's what I was thinking. It's got to be similar to the original. 1 by 2?
Or 1.5.
You want to go 1.5 by 2? I'm fine. That's similar, right? Let's go 1.5 by 2. 1.5 by 1, 2. Oh, look at that little thing. Call that Roman numeral, rectangle Roman numeral 2. 1.5 by 2. Let's see what happens. Do you think let's see what happens. Is the perimeter and area also cut in half from the original? Hey, 5, when you're ready. Perimeter. Oh boy. 18, area.
3.
Thank you. Perimeter got cut in half. Did the area get cut in half from the original? No. Oh, yikes. All right, one more so we could see a clear pattern. How the perimeters and areas work. Anybody? Jonathan?
15 by 20.
15 by 20. Hey. You really need, come on, 15 by 20. Just draw a rectangle out there, all right? We don't need it to be exact. How many of you are really counting the boxes for the area? Let's, hopefully not, right? We don't belong in here if we're just counting the boxes inside. 50. Oh, but I need it. Okay, if you're OCD about it, go ahead. I am too, but I'll skip that part here. Fresh cut, Jonathan?
Yeah.
Yes, I knew it! Win. Yes. At least I'm with the week. Professional, homegrown.
Homegrown.
Really?
Yeah.
Wow, a lot of homegrowns. Have I asked you already this year?
Yeah.
I have, and you've had it always homegrown?
Yeah.
Gel?
No.
Just natural?
Yeah.
Comb?
No.
Stop. Now I know you're lying. You're telling me you and Quanster over there, Rico Suaves, you just wake up and the hair looks that good. All parted off to the side.
Pretty much. One time it looked like Wolverine. It was all really weird.
So what'd you do then?
I kept it like that.
No, you didn't.
I walked around the day like that. It was a weekend at least, so I didn't have to go to school.
So you're saying your hair looked like Mahmoud Light?
Bro, what? What do I have to do with this?
For number one, I'm not your bro. Never will be.
Okay.
Okay.
Okay, fine. Okay. When I get a haircut.
No, this isn't your. Get your hair cut and I'll talk to you.
Well, what should
Okay.
I get? 'Cause
Even
asked
though
for,
we know,
I asked
yes,
for
small
Carlito
woodland
one,
animals
and
would
he
lose
pulled
their
out
home,
one, it was
but-
like,
I'll talk to you then.
shaving it all off.
Who does it at home, Jonathan?
My mom.
Really? Nice. Looks good. Nice. And I still doubt you guys wake up and it looks that way. You do something to it.
Do you wake up and it looks that
It
way?
absolutely does look that way. Yes, I have not seen a comb since maybe my senior year of high school. Yes,
Do you like gel it or like?
I do. Yeah.
Yeah.
When it gets, I don't need to now, but when it gets a little bit longer, I do. Style it in. No, it is professional. Yes, professional. This is actually, I haven't gotten it this short since probably when the barbershops closed in 2020. But I went there a couple over break and I was like, you know what? Let's roll. No guts, no glory. Let's shave it. So usually it's a 4 on top, if anybody's wondering, the Carlino special. 0 with a 4 on top, but I went a 1 this time. What's that?
I'll get that next time.
Yep.
Come to school, last day, like bald.
You're gonna have to go to Lowe's and get a weed whacker. Forget a barber shop for that if you want it that short. Oof. Just be coming out with my glasses on. Oh boy. All right, anyway. How about the perimeter and area of this one? 22 perimeter. 70. And how about the area for this one? 14, maybe next time. 21. 300. Okay, let's see what the pattern is here. Because you guys are noticing the perimeter always changes with the sides. If I double them, so does the perimeter. If I cut it in half, so does the perimeter. But the area doesn't follow that rule. And we got to figure out what type of rule the area follows. So let's fill out this chart to see what rule it follows. So here's what I want you to do. Take rectangle number 1 with rectangle original. Similarity ratio. And if you guys need a little recap, refresh, similarity ratio, what's the ratio of the sides? So start with rectangle 1 to the original. 6 to what? What's the 6 match up with? 6 to 3. Or I could go 8 to 4, but let's reduce that. What's that reduced down to? 2 to 1. So the similarity ratio for rectangle 1 to the original is 2 to 1. Now go to the chart above. What was the ratio of their perimeters? Look, 28 to 14. What's the ratio? Also 2 to 1. Now look at the areas. 48 to 12. What's my ratio? Not 2 to 1, but now 4 to 1. Next, now compare 2 to the original. What's my similarity ratio? 2 to 4, 1.5 to 3. Both reduces down to what now? 1 to 2. 1 to 2. Look at your table. Compare the perimeters to 2 to original. 7 to 14. What's it reduced down to? 1 to 2. Ooh, how about the area? Not 1 to 2, but 1 to 3 to 12. 1 to 4. And then our last one here. Ooh, we're going to have to do some reducing, huh? 15 to 3, 20 to 4. What's my similarity ratio? 5 to 1. If you need to do it on your calculator, do it on your calculator. 70 to 14. What ratio is that in reduced? 70 to 14. 5 to 1. And even if you had to guess, you were probably right. Yeah. Ooh. How about the area? 300 to 12. What's that reduced down to? 300 to 12. 25 to 1. All right, so let's talk about our conclusion here. Conclusion number 1, similarity ratio leave a little space, and perimeter ratio. Remember, similarity ratio of the sides. What do I know about them? Look at our chart. Why did I say ratio? Similarity ratio and perimeter ratio. What do we always know about them? Always the exact same, aren't they? That's what our table's proving here. Ooh, what about similarity and area, though? Ooh. So similarity ratio. Is that a true statement? Similarity ratio, the ratio of the sides and the ratio of the area is always equal. No, look at the darn table. They're not equal. Can you adjust it, though? What am I going to have to do every time in the similarity ratio to make it equal to the area? And as you can see, the answer is not multiply by 2, because that doesn't work for the third one. Look at 2 to 1, 1 to 2, 5 to 1, and that third column of areas. What am I going to have to do to the similarity ratio every single time to get the ratio of the areas? Go ahead, what do you got, kids? Square it. There you go. I got to square the similarity ratio. They're never equal. I got to square the similarity to get to the area. Questions before we start tackling this? All right. There's a theorem box on the next page underneath your graph, but we just wrote it in. All right, part C. All right, part C, that was your conclusion. We don't need to write this again. All right, we don't need to write this again. All right, let's try this out. Now actually using figures. Find the perimeter ratio and the area ratio if they're similar. First thing I need from you guys, what's the side ratio between these two? I don't know if they're rectangles or not, or squares. I'm not going to guess. But what's the side ratio? Don't overthink this. It's right in front of you. What's the side ratio for figures in number 1? What's the side ratio? Don't overthink it. 15. What's the ratio of the sides? Don't overthink it. It's right there. Name 2 corresponding sides.
4 and 5.
Done. We're done. Right? Done. 4 and 5. It's 4 to 5. Here's how I'm going to abbreviate that because I don't want to write similarity every time. Ready? Here's my abbreviation for similarity. S1 over S2. That's the similarity ratio. And then, Serena, what is it again? 4 to 5. Good. It's 4 to 5. That's similarity ratio. That's huge because now, if you know that, guess what P1 over P2 is going to represent? Perimeter ratio. We just learned something big about it. What's up, Griff?
4 to 5.
Oh, you're going to tell me. Yes, 4 to 5, because they're always equal. Huge misconception here. Am I saying right now that the perimeter of the small one is 4 and the perimeter of the big one is 5? Is that what that means? No. Here's what it means. If you found me the perimeter of the small one and put it over the perimeter of the big one and reduced it, you know what it's going to reduce down to? 4 to 5. All right? That's not what the perimeter is. That's what the ratio reduces down to. All good. Questions? All right, we got one more. Area. You tell me 4 to 5, get out of here. The ratio is not 4 to 5 for the area. What do I need to do to the similarity ratio to get to the area? 22? Thank you. So it's going to be 4 squared, 5 squared. 16 over 25. Hey, again, am I saying the small area is 16? No. I'm just saying whatever the areas are, put them on top of each other and reduce, it'd be 16 over 25. All right, this is not giving you what the area is. Questions? All right, a little bit more difficult on this next one. Can you figure out the side ratio? Because that's what I need to get perimeter and area. Can you find out what the side ratio is? I know it's 3, right, on the small triangle. Can you figure out what the 3 would match up with? And remember, match up, get the congruent angles, smack right on top of each other. And tell me what side the 3 would be right on top of. Match up the congruent angles. What would the 3 match up with in the other triangle then? Oh, 16. 5. Any issues on how we got 5 and not 8? I can show you a little quick trick, and we're good. All right, let's roll. Perimeter ratio. What's the ratio of the perimeters now? Come on, be big. 21. Also 3 over 5. They're always equal. How about the area ratio now of those two triangles? What's my area ratio? Didn't want to do that. 16. Square them. You got it. Any issues before we use this a different way? So everyone's good. Now here's what I'm going to do. What if you knew the area ratio? Could you get me the similarity ratio? That's what we're doing now. Let's go backwards. 1 over 4. So now, take the square root of those. No issues here. I don't even need a calculator, I hope. What's my similarity ratio? 1 over 2. I believe, too, in your calculator, if you did do square root of 8 over square root of 32, it'd give you 1/2 back. So even if you had to use your calculator and you forgot to reduce. All right, what about 2 circles? With an area of 128 pi over 18 pi. Still need to take the square root, right? But that's not pretty. I could probably plug it in my calculator and be fine. If I reduced it, what's going to cancel? Pi's will cancel. And 128 over 18 should be a couple perfect, literally, numbers. 16 over 9. Yes, did I get that one? Thanks for the help. No. Yeah, 64 over 9. Thanks for helping me out. So the similarity ratio, square root of 64 over square root of 9. 8 over 3. All right, all that work, what's your deal?
Does it matter how we write it? Like, do we have to write it in like a fraction or like ratio?
I don't care.
All right.
They're both ratios. All right, all that work for this problem here. All right, all that work for this problem right here. You got 2 rectangles that are similar. One has a short side of 6. The other has a short side of 9. The smaller one's got an area of what, 48? What's the area of the bigger one? Here's where we're going to put all that work to use now. I'm going to write something up on the board. You tell me if it's right or wrong. 6 over 9. I'm going to find the other area by doing 48 over x. Is that a correct statement? That 6 over 9 is in the same ratio as 48 over the other area. Better be telling me no, because if you're going to say yes, this is what you're telling me. This is true. Is that true? Absolutely not. We've gone over that the whole time. So make it true now. What do I need to do to this proportion to make it true? 8. Yes. Square the 6 and square the 9. Now you can cross multiply. All right. The side, you should never be setting the sides and the area equal. Square the sides, then set them equal. And now you can cross them up. Mm. $108 square feet. Questions? Rules are the rules. Not a big fan of you skipping the homework tonight, but okay. Rules are the rules. And you know what? I don't feel bad that 2 of you are going to get voted out right now either. Shayna, Charlotte, Caitlin, head on up.